projects. In this video, we are going to explain about the project that is Intrusion Detection System for Wireless Sensor Networks, a machine learning based approach. Before getting into the execution, first let us understand what is the project about. Wireless sensor networks or WSNs, they are basically systems where small sensor devices work together to collect, process and transmit the data. Think of these sensor nodes as tiny helpers placed in different environments that may be in farms, factories, or also even in cities to gather the information like temperature, movement, or light levels. These nodes they can connect in different patterns or topologies like a star where everything linked to one central node or mesh where they're all linked together to each other. These makes them super flexible for a variety of tasks. Now, why these WSNs are so important? They are incredibly cost effective and they are energy efficient, meaning they don't need a lot of power or money to set up or run. That's why they are key part of IoT, that is Internet of Things. IoT is all about connecting devices and sharing data. And WSNs play a big role in making that happen, especially for things like monitoring an area, protecting resources, or tracking the movements. But here is the flip. Since these networks use wireless communication, they are open to risk. Imagine someone sneaking to your Wi-Fi network. It's kind of like that. Unauthorized access or malicious attacks can happen, which could mess up the system or even steal the sensitive information. That's why having strong security measures in place is absolutely essential to keep these networks reliable and safe. With the rise of IoT devices, wireless networks have become more vulnerable to security threats, and intrusion detection systems are essential for monitoring these. So, here where intrusion detection system comes into the play and they are important for monitoring the systems. They quickly identify unauthorized activities and also neutralizes potential threats. In fast-paced, resource-limited environments, these ideas helps to ensure network reliability by detecting irregular behaviors efficiently. Threats like flooding, injection, and impersonation. So, threats like flooding where networks are overwhelmed with the data. Injection is where malicious data is introduced, and impersonation is where attackers pretend to legitimate users pose significant risk to network integrity. So these attacks require specialized detection methods tailored to safeguard wireless networks. So ideas that is intrusion detection system is designed to catch these threats and maintain the integrity of the network by recognizing unusual patterns of the activity. As IoT continues to grow, the need for advanced IDS systems becomes even more critical to prevent disruption and also the data breaches. Adapting ideas to keep up with the emerging threats ensures the security of wireless networks, especially as cybersecurity risks evolve. So, to overcome all these issues, the proposed system follows a structured approach to improve the accuracy and reliability of the intrusion detection in wireless sensor networks. So, first we start with the feature selection. So, first, what do we do is we select the important features that enhances the data set by addressing null values. So, first we begin with a careful feature selection process that enhances the data set by addressing all the null values and refining the set of features used for analysis. This ensures that the data used for training the model is both relevant and also clean. To further prepare the data, we apply standard scaling. So we apply feature scaling techniques, that is the standard scaling. It is standard scalar to scale the features, making them uniform and also easier for the model to interpret. Once the dataset is ready, the system trains a convolutional neural network, that is CNN based models, which is especially designed for detecting and preventing intrusions across multiple categories of attacks within WSN environments. And the CNN model is trained to accurately identify different types of threats such as flooding, injection, and impersonation. To evaluate the effectiveness of the proposed model, we compare it with the performance against other advanced models that are deep learning with different layers, that is 3 and 4 layers, and also long short term memory, that is LSTM networks. The proposed CNN model has performed well than these models. Moving on, and furthermore, we assess the system's performance using several key metrics that are precision, recall, FN score, and macro average, ensuring that only it detects not only detects intrusions accurately but also minimizes errors and provides a reliable security solution for WSNs. Moving on, in the extension of the project, as the extension of this project, we have incorporated stacking classifier, which is an ensemble model to further improve the accuracy. So what this does is it combines the predictions of multiple individual models to create a more powerful and accurate final prediction. Instead of relying on just one model, this method takes the strengths of individual, that is different models, and combines them, leading to better overall performance in detecting and classifying intrusions. As a result, the system achieves the highest accuracy in intrusion detection compared to individual models. Additionally, in this project, we have developed front-end using Flask framework. So this interface allows users to interact with the system, that is, interact with the intrusion detection, making it more practicable and accessible. The front end allows it also includes user authentication. So the front end includes user authentication. This ensures that only authorized individuals can access and test the system. This adds an extra layer of security and makes the system more user friendly. Moving on to the implementation of the project, to implement, we have followed the steps in the flow of work. So, first, we import all the necessary libraries that are pandas, numpy, scikit-learn, and TensorFlow. Pandas for data handling, numpy for numerical operations, scikit-learn for machine learning, TensorFlow for deep learning. Then the next step is we work with the different intrusion detection data sets such as KDD Cup data, NSL KDD, UNSW NP15, and AWID. So in this project, we are using all the four data sets to train the model so that they will be able to detect the attacks. This helps us to understand the structure of the data. So here we explore the data set. With that, we can understand the structure of the data and choose the relevant features for the model. The next following step is data processing. So this step involves cleaning the data by removing any duplicate entries and handling missing or incorrect values to ensure the data set is ready for model training. Then we visualize the data using graphs and charts to identify patterns, distributions, and potential outliers. This helps in understanding the data better and identifying features that might be important for detection. Moving on to label encoding, here the label, that is the target values in the data set, are encoded into numerical format. Here categorical variables, specifically categorical variables, are encoded into numerical because machine learning algorithms only work with the numerical data. So we convert categorical values into numerical using label encoding. And coming to feature selection, we identify and select the most relevant features that contribute to detecting the intrusions, which removes the irrelevant or redundant features that don't add value to the model's performance. Then we split the data into training and validation sets. The data set is split into two parts: training set and testing set. Training set is used to train the models, and validation set is used to evaluate the models. The next step is we initiate machine learning models based on the processed and features selected using algorithms like CNN, DNN, and other intrusion detection algorithms. Coming to training and building the model, in this step we train the selected models on the training data set, allowing the models to learn patterns and the date in the data related to intrusions. And we evaluate them using accuracy, precision, recall, and offense score, and we compare them through graphs. Coming to the part of front end, we develop a user-friendly interface, front-end interface using the Flash framework, enabling users to interact with the IDS. We have also set up registration and login functionality using an SQLite3 database for user management. And the user, they will be able to give the specific feature values that may be related to network attributes into the front end for the intrusion detection prediction. Then that will be pre-processed at the back end, which includes transforming the data into format suitable for trained model to make the predictions. And the pre-processed data is fed into the trained model, which will give the predictions that will give the intrusion detection that will generate the attacks. And that will be finally displayed in the front end. So this is how we have implemented the project. Coming to the algorithms used, these are the algorithms used in the project. This is the extension model and this is the proposed model. And here, rest all we have built them for comparison purpose. Moving on to the requirements to implement this project, we need basic requirements which are hardware and software. Coming to hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Coming to software, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. Now, let's execute. To execute, we have to open the code folder which contains source code files. So these are the source code files in the code folder of the project. Here in these folders, we have the dataset that is used in the project. So in these folders, we have the dataset that is used in the project. We will be using all the four datasets to train the models individually. And here in the models folder, we have the .h5 files, numpy files, pickle files. So that in that we will be having the algorithm information that will be loaded into the project code during runtime of the application. And this is the app.py file. This .py file contains the information related to front-end logic of the project. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. And here we have individual Jupyter Notebook files. So these are the Jupyter Notebook files which contain the combination of code, graphs, and outputs all in one place. And it allows users to write and execute code in individual cells, which makes it popular choice for the data science. And in this AWID Jupyter Notebook file here, we will be loading this AWID dataset, and then we will be training all the models on this dataset. Similarly, KDD Cup, NSL KDD, and also UNSW, we will be doing individually. Coming to this signup.db file, this file is a database file which is used to store the user information. So now let's execute. Copy the path of the code folder from the address bar of the file explorer. I'm copying the path. Now open the Anaconda prompt. Here, give the command cd followed by the space, paste the copied path. Now click on enter. Here, if you observe, current directory is changed to the code folders path. Now we have to compile app.py file. So give the command python space app.py and now click on enter. This will compile app.py file and it will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now copy this local link provided by the Flask framework and paste it in any web browser. I've copied it. I prefer Google Chrome, so I will paste it in that. Paste the link here, click on enter. This is the web page of the project which is displayed in the browser and this is developed using Flask framework. Now click on register. Let's register first. So if you are registering newly, we need to fill in all these details. I have already registered, so I will directly sign in. Click on sign in. And here we are supposed to provide your username and the password while you sign in. Click on login. We have logged in successfully and we are redirected to prediction page of the project. By default, we are redirected to AWID prediction page. So let's see what is this. As we are doing prediction for AWID, KDD Cup, NSL KDD, UNSW, NB15, we have all those four under prediction. So let's do prediction for the first AWID and do the intrusion detection. Click on that. So here you can see parameters, right? So here you can see parameters, right? These are the parameters that are supposed to be entered. Based on that, we will be getting the prediction. So the after applying feature selection, these are the important features that have been selected for the prediction, which adds more importance for detecting the attacks. Let's understand them. First, we have is the frame offset shift. This refers to the offset in the packet data where the frame starts accounting for any shifts or adjustments in the data structure. It indicates the position of the frame start within the captured data. Coming to frame time epoch, this represents the timestamp of the frame, recorded as the number of seconds since the Unix epoch. That is, it gives the exact time when the frame was captured. Frame time delta. It is the time difference in seconds between the current frame and the previous ones. It helps to measure the interval between frames and that can be used to analyze the timings of events in the network. Then we have is frame time delta displayed similar to frame time delta, but this value is displayed in a human readable format, often rounded for ease of visualization. It provides a visual representation of the time difference between frames. Coming to frame time relative, this is the timestamp of the frame relative to the first frame captured in the trace. It shows the time elapsed since the beginning of the capture session. Coming to frame length, it is the length of the frame in bytes, including headers and payload. It indicates how much data is carried by frame and helps in network traffic analysis. Coming to radio tab flag short guide, it is a flag in the radio tab headers that indicates if short guard interval, that is SGI, used the transmission. SGI is a feature that reduces the duration of guard intervals in the Wi-Fi transmissions, improving data throughput. And the next one we have is WLAN FC type. This field indicates the type of the frame in the Wi-Fi protocol, for example, data management or the protocol that is the control. It helps to classify the frame's purpose within the network. Then we have is the WLAN FCDS. It is the data subtype field in the Wi-Fi frame header, specifying whether the frame is intended for distribution between access points or directly between the stations. The last one we have is the WLAN FC frag. This field indicates whether the frame is part of fragmented set of frames. It is used to determine if the frame has been broken down into smaller pieces for transmission or it is incomplete unit. So this is about the parameters of AWID dataset. Let us enter them. In all this, we have some test cases that we have in the sample file. Let's open the model folder. So these are the sample files in which we have test cases. As we're doing prediction for the AWID dataset, let us open the sample AWID. So here, let's see how many classes we do have. So total, we have 3 classes. Let's check with the class 0 and let's fill in all the values. So let's try with the first test case of the class 0. So copy the value of frame offset shift. Then the next one is frame time epoch, frame time delta displayed, sorry, frame time delta displayed, frame time relative, frame length. Next we have is radio tap it is 1. 0 is the WLAN FC type. And next WLAN FCD is 1. And last we have is the 0. Now click on predict. And the given input will be pre-processed at the backend and then train model will be giving us a prediction. So here 0 refers to no attack and it is normal. So there is no attack detected and it is normal. Let's try with the class 1. Click on AWID again. So here let's try with the second case. So copy the frame offset shift, frame time epoch, frame time delta, frame time delta displayed, and then frame time relative, same frame time length is, and the next we have is radio top is 1. And here FC type is 0, FCDS is 0, FC frag is 0. Now click on predict. Now let's see what will be predicted. So here we got the prediction that attack is detected and the attack type is impersonation. It is impersonation attack. There is attack and that attack type is impersonation. That is, this attack is impersonation attack. Let's try with the last class, that is class 2. Click on OK. So let's try with this case. Click on AWID. So copy it. Frame of shift, frame time epoch, frame time delta, frame time delta displayed, frame time relative, frame length. This is the value that we have copied. Radio tap is 54. FC type is 8. 0 is the next value, that is FCDS is 0 and all the rest two values are also 0. Click on predict. So here we got the prediction that there is attack and that attack is nothing but the injection attack. So here injection attack is detected. Here we have done the multi-class classification. Now let's try with the other data sets. Now let's try predicting KDD cup data set. Click on that. So here you can see parameters, right? Let us understand them. So first we have is the logged in value. This refers to whether a user or a device is currently logged in to the system network. It can be binary value indicating whether the user is authenticated and connected. Coming to root shell is a parameter that indicates whether the system shell has root access. In network security, it is crucial to identify if an attacker has gained root privileges on the system, as this allows full access to the machine. Coming to error rate, it measures the rate of the system errors such as failed attempts, crashes, or any other system level errors that occurs over a given period. It helps to identify possible issues or malicious activities that disrupt system stability. Coming to SRV's error rate, this is the rate of service errors, that is the errors that occur during a service or application execution. A high service error rate can indicate misconfiguration performances issues or attacks aimed at overloading a service. Coming to same SRV rate, this parameter tracks how often the same service is accessed from the same source over a given period. A high rate can indicate repeated attempts to interact with a particular service, potentially signaling an attack or malicious activity. Coming to destination host SRV count, this refers to the number of times a particular service is accessed on the destination host. It helps to track how often a specific service is being interacted with and can be used to detect abnormal patterns. Coming to destination host, same SRV rate, this tracks the rate at which the same service is accessed on the destination host. A spike in this rate could suggest malicious activities like brute force attacks or scanning attempts. Coming to DST host, that is destination host, same SRC port rate. This refers to the rate at which the same source port accesses the destination host. Monitoring this rate can help to detect any suspicious patterns in traffic that may indicate a scanning attack or exploitation attempt. Coming to destination host, error rate. This is the parameter that measures the error rate on the destination host. High error rates could signal a malfunctioning service or an ongoing attack, such as DOS, that is denial of service attempt. The last parameter we have is the destination host SRV error rate. This tracks the rate of the errors for a specific service or the destination host, similar to the service error rate. A higher than normal rate may indicate issues with the service or malicious attempts to exploit vulnerabilities. So this is all about the parameters of KDD cup. Let's enter these values for open that sample KDD. For that, we have to open the sample KDD file. So here we have multiple test cases. Let's apply filter. We have total 5 test cases. Let's check with the class 0. So here, let's try with the first case where logged in value is 0, root shell is 0, 1 is the error rate, 1 is the SRV error rate, and same SRV rate is 0.12. Destination host is 17, destination host same SRV is 0.07. And next we have is the 0, that is the host same SRC port 1 and 1. Now click on predict. So here we got the prediction as attack is detected and the attack type is DOS attack. So here we got DOS attack. I mean here DOS attack has been detected. Now let's check with the other class. So now let's check with the class 1. Let's try with this case where logged in value is 0, root shell is 0, error rate is 0, SRV is 0, same SRV is 1, and destination host SRV is 36. Destination host same SRV is 1. Destination host same SRC port rate is 1. Destination host error rate is 0. And the next values we have is 0. Now click on predict. So here we got the prediction that there is no attack and it is normal. Now let's try with the other case. Let's try with the class 2. So now let's try with this case where locked-in value is 0, root shell is 0, server rate is 0, service server rate is 0, same SRV rate is 1, destination host SRV is 32, destination host same SRV is 1, 0.03, 0.06, and 0.06. Now click on predict. So here we got the prediction that attack is detected and that attack type is probe. So here class 2 refers to probe and class 1 refers to there is no attack. Now let's try with the class 3 and see what will be detected. So let's try with the KDT cup only. So let's try with the first case where locked in value is 1, root shell is 0, server rate is 0, SRV rate is 0, same SRV is 1, destination SRV is 1, next is 0.25. The next value is also 0.25. Then we have the next two values as 0. Now click on predict. So here we got the prediction that attack is detected and that attack type is R12 attack. So here R12 attack has been detected. Now let's check with the last class. Click on OK. We are doing for the same KDD cup. So now let's try with this case. The logged in value is 1, root shell is 0, error rate is 0, and SRV error rate is 0. 1 is the same SRV, 255 is the destination SRV count. Destination host, same SRV is 1. 0 is the destination host, same SRV, same SRC port rate. And the next two values are 0. Now click on predict. And here we got the prediction that attack is detected and that attack type is U2R attack. So here U2R attack has been detected. Now let's check with the, we have completed all the classes. Now we have to shift for the other data set. Click on NSLKDD. So here you can see parameters, right? So here we can see the same type of parameters because initially we did prediction for the KDD Cup 1999 dataset. This is the original dataset used in 1999 KDD Cup competition. And coming to this NSL KDD, this is the refined version of this KDD Cup with some improvisation. So that is why we have the same features. Let's enter these values also. For that, open sample NSL and see what are the classes in this data set. So here also we have 5 classes. Let's try with the class 0. Click on OK. So let's fill in all the values where logged in value is 0, root shell is 0, error rate is 1, SRV error rate is 1. The next one is 0.1725, 0.1, 0, 1, and 1. Now click on predict. So here we got the prediction that is attack is detected and that attack type is DOS attack. Let's try with the class 1. So now let's try with the class 1. Let's try with this case where logged in value is 0, root shell is 0, error rate is 0, same SRV rate is also 0. Then next we have is, sorry, this value is 1. No, it is 0. Next, we are supposed to enter is the same SRV, that is 1. Destination host SRV is 2. Then destination host same SRV is 0.01. Destination host same SRC port rate is 0.88, 0, and 0. Click on predict. So here we got the prediction that there is no attack detected and it is normal. So here attack has been not detected and it is normal. Let's check with the class 2. Click on OK. So click on NSLKDD as we're doing for the same data set. Let's try with this case where lockdown value is 1, root shell is 0, setter rate is 0, SRV setter rate is 0, 1 is the same SRV rate, 22, 1, 1, 0 and 0. So here we got the prediction that is attack is detected and that attack type is prob attack. So here attack has been detected and the attack is prob. Let's try with the one more class. Let's select class 3. Click on OK. So let's try using this case. So here locked-in value is 1, root shell is 0, setter rate is 0, SRV setter rate is also 0, same SRV is 1, destination SRV is 1, and the next values we have is 0.25, 0.25, 0 and 0. Now let's click on predict. And here we got the prediction that attack is detected and that attack type is R12 attack. So here R12 attack has been detected. Now let's check with the other class that is class 4. Click on OK. So click on NSLKDD again. Let's try with the first case where lockdown value is 0, root shell is 0, setter rate is 0, same SRV setter rate is 1, 255 is the, sorry, here also we are supposed to give the value 0 and the next value is 1. Then the destination host SRV count is 255, same SRV is 1, port rate is 0.010, and the next values that are 0. Now click on predict. So here we got the prediction that U2R attack is detected. So there is an attack and that attack type is U2R attack. So now let's try with the other data set that is UNSW-NB15. Click on that. So here we have set of parameters. These we are supposed to enter. So first we have is the rate. It is the rate at which events or actions occur over a time period, useful for detecting anomalies or attacks. Coming to STTL, that is state TTL, it is the time a packet or a session is allowed to live in the network, helping detect network loops or unusual packet lifetimes. Coming to SWIN, that is sender window, it is the size of the sender's window in TCP indicating how much data can be sent before receiving an acknowledgement. Abnormal values may signal buffer overflow issues. Coming to deload, that is download, it is the amount of data downloaded which can identify data exfiltration or abnormal transfer activity. Then we have is CTSRV SRC, that is the track the source IP of connections to a server. It is useful for monitoring access and detecting unauthorized attempts. Coming to CT state TTL, it is a TTL value for connection table entries helping detect abnormal connection behaviors. Coming to CT-SRC depot LTM, it is the last time a connection was made from a source to a destination port, helping to identify suspicious patterns. Then we have is CTDST Sport LTM. It is the last time a connection was made from a source port to a destination, tracking unusual access patterns. Here we have CTDST SRC LTM. It is the last time a connection occurred between a specific destination and a source, helping monitor traffic flows. Then we have is CTSRV DST. It tracks the destination IP for server connections, useful for ensuring legitimate traffic and ensuring unauthorized access. So this is all about the parameters. Let us enter them. For that, open sample UNSW. So here we have binary class. Here we are going to do just binary classification. We do have only 0 and 1 class. Let's try with the 0 class. Let's enter the values. So copy the rate, paste it. And the next values STTL is 62, 255 is the spin, and win is also 255, that is download. CTSRC is 1, TTL is 1, deport is 1, export is 1, SRC LTM is 1, and CTSRV DST is 1. Sorry, we have entered wrongly. One. We are supposed to enter four ones. 1, 2, 3, 4. And here we are supposed to give the number 2 and here 1. So now click on predict. So here based on the given inputs, we got the prediction as no attack is detected, and that attack, I mean, it is benign case. Here there is no attack and it is benign case. Let's check with the last class. That is 1. So let's try with this one. So here, copy the rate, paste it. The next one is 254, 255, 255, 1, and we have rest all values as 1. Click on predict. So based on the given input here, we got the prediction that attack is detected and that attack is bot. So now we have done binary classification with the UNSW dataset. All the first three data sets, I mean all the predictions with the first three were the multi-class classification, and with the last one we have done the binary classification. Now let's check with the graphs. Click on graph. So here the first graph we have is for the AWID. So first we have the graphs for the AWID dataset. So here are the types of attacks in the AWID. Here on x-axis we have all the attacks, and on y-axis we have count of each attack. So this is the sample outcome which shows the distribution of the all classes. And here this is the correlation matrix graph. This shows the correlation between variables. And here we have accuracy comparison graph. Here on x-axis we have accuracy score, and on y-axis we have all the algorithm means. These are the algorithms trained on the AWID dataset to detect the intrusion attacks. And this is precision comparison graph. Here we have recall, FN score. This is the KDD cup dataset sample outcome graph. Here on x-axis we have all the types of attacks, all the types of classes, and on y-axis we have count of each attack. And here this is the correlation matrix. Similarly, we have accuracy, precision, recall, and FN score. These are all the algorithms trained on the KDD cup dataset. We do have NSL KDD sample outcome graph. So this is the NSL KDD sample outcome. Correlation matrix, accuracy, precision, recall, and FN score. Similarly, we have for the UNSW NB15. It is for binary class. That is why we only have the two classes here. Here on x-axis we have 0 and 1. 0 is the benign. That means there is no attack, and 1 refers to the attack. Here on y-axis, we have count of each class. And this is the correlation matrix. Here we have accuracy, precision, recall, and FN score. Now click on logout. In this way, just by giving parameters to the system according to the data set, then we will be getting the prediction. If you're doing multi-class classification, then if we give the inputs, if there is attack, it will detect which type of attack it is. If there is no attack, it will tell that there is no attack detected. Coming to the binary case, if there is attack, it will detect the attack. If there is no, it will show that there is no attack. So this is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.